welcome to the video. Firstly, a bit of an apology for the gap since the last video, but I've been quite busy actually working on the project. I'm going to show you next the project timeline, and you'll see that I've got so much to pack into quite a short space of time, so I'm having to keep on top of things. So hopefully that'll explain why.
This is the project plan that I'm working to on the Beast Car project. It's bookended really by the first Rosser event of the year, which happened at the start of June at Clanbedder, and at the end, the goal is to be at round 3 at Elvington in mid-September with a running car. So obviously everything's got to fit in to that time in between that you see there. The first step that I mentioned in my last video is the powertrain selection. So that comes right at the start, and then immediately following that is the chassis and body design, including any CFD work that I want to do. But of course, to be able to build the car and make it in time, I'm going to have to order some of the parts for that earlier that have a longer lead time. So the sheet carbon parts is a crucial step here. So I need to order those at the end of July in order to get them in time to build the car for Elvington in September. Other overlaps that are going to have to occur, I'm going to have to be manufacturing some of the chassis parts as well in August, so that I can get all the parts together in time to build and test. I mean, there'll still be manufacturing going on right to the end, probably with the body shell. So today we're going to be focusing in on this stage here in July. So fundamentally it's the design of the chassis that's going to be done in this stage in order to get that sheet carbon part order off in time.
In this video, I'm going to be focusing on the design development of the chassis of the Beast car. This is one of my favourite stages of the process because design engineering, it's all about turning requirements eventually into completed designs that you can manufacture and see turned into the finished vehicle. But that's done with a lot of problem solving, a lot of thinking's involved, optimization, iteration, and that is what I really have a lot of passion for, and I hope you can see that in the video. And I hope by showing the stages I've taken along the way, you can see that development taking place up to the final designs.
I mentioned that the requirements are an important part at the start of a design engineering project. Well, I want to show what that means in the context of the Beast Car project. So let's have a look. To start with, I've got to be able to fit in the powertrain that I've selected. So that means the batteries, the motors, the speed controllers, and also any control systems that are needed for the car, like the flight controller, power distribution unit, braking system. All of that has got to fit in the chassis design that I come up with. I also want to protect the batteries, so in the event of a big crash, the batteries themselves are sort of packaged in the center of the car, well secured, so they're not going to fly out and explode everywhere. My goal is to use standard wheels and tyres. So on my original car, I made my own wheels and tyres. This was very time consuming. Although maybe it saved a little bit of money, but in the context of this project where I've got so little time, I need to save wherever I can, and using standard wheels and tyres is going to be a really good way of doing that. I decided to include suspension on this car based on my learnings from my small car that I made. Initially I ran that with no suspension and it was very bouncy, and if the wheels aren't on the ground, then they're not able to transmit any power and accelerate the car forward. So I saw this as a crucial aspect of my design of the Beast car. And with that suspension system, I want to be able to change the ride height to allow me to run different diameter wheels and tyres, which could help me optimize the gearing, given that I can't change the motor kV. The only other way of changing the gearing is, in addition to the wheel diameter, is the number of cells that I'm running. So there is a couple of options, but they're quite limited. And adjusting the ride height is going to help me do that. I want to have a feature in the car that allows the front and rear wheels to be aligned to one another. On the original car, I used like piece of aluminium section that I lined up to the front subframe, and then used my eye basically to make sure it was aligned to the rear, and then I could adjust that if needed. But I want a sort of more reliable method for the beast car. A goal all along really is to minimise the frontal ebb, because that fundamentally will reduce the drag on the car and allow it to get a higher top speed for the same input power. So there's a motivation for doing that. Ideally, the car will be easy to work on, so I'll try and keep that in mind as I design it. And manufacturing wise, it's got to be within my capability to manufacture, which means that I'm concentrating on making parts with sheet carbon fibre, because that is a process that's been offered to me. And in addition to that, I can use aluminium extrusions that are then drilled and cut to shape. And I've found that I can use a lathe and a milling machine at a local machine shop. So that is also just about within my capability, but I don't want to have too much of those more advanced processes, because it's going to add more time to the manufacturing stage. Finally, we've got strength and stiffness as requirements. So by strength, I mean that the car will stay intact during its speed run. All the wheels will stay attached, which is obviously a bare minimum. And by stiffness, I mean that the car isn't going to be too flexible. Like, for example, the chassis could be flexing in between its wheels and hitting the ground. That's obviously not desirable, because it'll slow the car down. And the wheels should stay pointing in the correct direction, like vertical, pointing straight ahead, and giving the best possible contact between the tyre and the ground for the best traction possible. Those are the requirements that are going to be guiding my design engineering as I develop the Beast Car chassis. Hi, welcome to Onshape. So I'm going to just show you where I started with my chassis design now. In terms of wheelbase and track, which are sort of some of the fundamental dimensions of a chassis, I started with just 2 times what I'd had on my original small speed car. So this was a wheelbase of 620mm and a track to the outside of the wheels of 262mm. So it's quite a large footprint it's got there. This is with 100mm diameter wheels. You can see I've got a central spine type layout with leaf spring style suspension and a common subframe on each corner, which I'm going to show now. So the subframe is made up of a aluminium L bracket with the motor bolted to it. As I mentioned before in one of my previous videos, I've found the model for the motor in Onshape already, which was really useful. And then via an adapter, the standard GT speed car wheel is going to be fitted on there. And for commonality, I've got the same on each corner. So I've modelled up a battery as well, so that shows that there's plenty of space for the 4 batteries I'm planning to fit in within the layout. But fundamentally, there's still quite a bit of improvement to be done with this design. But it just got me started. And it gave me something I could try wrapping a body shell around. I'm going to go into detail on the body design development process in one of my subsequent videos, so I'm not going to go any further into that at this stage. So I'm now going to show you the next evolution of my chassis design. So the way I work is that every now and then, if I'm going to make a big change to my design, which ends up being a whole new layout, I just take a copy of the whole project. That way I can go back and revisit what I've done previously in case it doesn't work. In case the new design I've done doesn't work out, I can actually go back to the previous one. But in this case, it's quite useful because I can go back and show my development process or a bit of it. So at this stage, I decided to use like C-shaped subframes instead of L-shaped that I had before, because I decided to use these little rubber cones. If I hide that off, you can see it there. So the idea would being that this piece here would be like a bulkhead that's fixed to the chassis, so that doesn't move. And then when the C-shaped subframe moves up, this little rubber cone gets squashed between the lower bit of the C and the bulkhead thing there. And I actually decided to put a little rubber cone on the upper part as well, eventually to arrest the sort of downward movement of the suspension in droop. So that is something that I ended up carrying forwards. You can also see this is a leaf spring here, which will be secured to these aluminium U sections, one on each side. And it's also got this top plate here that links the two sides together. So the idea of that being that when there's the weight of the car on each wheel, if there's only this lower leaf spring thing, the wheels might tilt inwards because of this spring bending in the middle. But with this extra spring here, I thought that this would brace between the two sides quite effectively. So it's shown a bit of progress, this design, but then I didn't really like these U sections that I was using because they're actually quite heavy, and also they didn't really protect the batteries that well. I think this was about as deep a U section as I could get, and yet the battery's still sticking out the top by some significant amount. Okay, so yeah, time to move on to the next iteration. This next iteration is a bit of a baby step onwards from the previous one, really. Just adding a bit more detail, but keeping the same overall layout, which you might be surprised at given what I just said about these aluminium U sections a second ago. But what you can see I've added is if I hide one of the wheels, I've added the mechanical brake in, so I could get a bit of an idea about how I was going to do that. And I've tried to work out how I'm going to mount these bulkhead pieces that don't move to the chassis. They've got to be quite rigidly held, so they'll be supported both at the front there and with screws going through into the edges of the aluminium U sections there. But fundamentally, it's a similar layout to the one we just looked at. Another key difference that I've noticed is I'd gone to this layout where the little rubber cones are actually screwed into the aluminium subframes above and below the bulkhead piece. So you can imagine if the wheel and the subframe moves up relative to the chassis, this lower spring will get squished, and if it's going down the other way, then the upper spring will get squashed. And I was trying to keep in mind how I was going to vary the ride height of the car, and you can't really see it in here, but it isn't modelled in. The idea being that you would change the spacing of the spring off the chassis to raise up the wheels relative to the chassis, which would actually reduce the ride height. But there's a bit of difficulty there because this bulkhead piece would also need to move, otherwise these rubber cones would stop the thing moving upwards. This is the end of this layout, really. The next one I'm going to show you it'll show a massive step forward, so let's go on to that one now. So what I'm showing now is effectively my final design. The reason for that is because once I'd got this concept in, I just kept adding more and more detail to it until it became my finished design, really. Let me just build it up gradually and then we can see where the changes are. So I'll start with the chassis itself, which is this assembly here. It's gone from those aluminium U sections to just two aluminium L sections, which is the width of the length of the battery apart. So the batteries are going to stack up. I'll just put them in. They're going to stack up 1, 2, 3, 4 lengthways in between those two side rails. So once they're clamped in by this top plate here with some nice branding on it there, yes mate, Steve Eng. Once they're clamped in by that, they're really going nowhere. So even if the car has a huge crash, the battery should stay protected in there. I'll explain what these funny looking blocks are for later on. But anyway, that just shows the chassis itself there. So if I hide those off and just put one of the suspension systems up. So if I hide off the wheels, yep, there we go. So it might, I'm just going to hide off that front bulkhead as well. Then we can see into the thing. So you can recognise these little rubber cones from earlier. So I hope you see that there's a bit of, the evolution of the ideas is shown there, I think. And I've gone from having that lower leaf spring piece and then the one cross piece at the front to just having two identical leaf spring sections. And a cunning feature of this is that the leaf springs are actually aligned to the L sections on each side of the car. So by doing that, I can make sure like the front set of wheels are aligned to the rear set of wheels without having to have any extra parts added on. As long as these parts are made accurately, that should all work fine. And then these subframes are aligned to the springs just by using this edge here. So these holes will be clearance holes that you'll set that up to that edge and then tighten the two parts together. Ride height adjustment, then we're going to achieve that by using these little spacers that can be inserted in the different positions there. So to raise the ride height, you'd actually take spacers out from this underneath position here, and there'll have to be corresponding spacers between this little bulkhead support and the chassis. So you'll have to take those out as well. Oh, sorry, I'll have to take them out. The brakes, they're completely designed there. There'll be some rubber friction material glued onto this purple piece there, and it's got a little ball joint in here that the servo turns to push it onto the bell housing of the motor. You can see the wheel adapter there as well that allows the standard wheel to be fitted. So let's add the chassis back on. You can see how that interacts with that L section there, giving the alignment of the whole assembly to the rest of the chassis. What else can I show there? So the batteries are there. Then there's like an electrical section that goes in the remaining part of the chassis behind the batteries. I've tucked all the speed controllers under this aluminium plate for protection, really. And I was worried about if one of the tyres lets go and the speed controls are in the sides here, they might get hit by bits of rubber. And that's actually one of the functions of these plastic blocks here that are going to be bolted to the L sections. They're going to protect the wires that are going to run in this area from any impacts from any bits of tyre. But also, if the car flips over, they're going to protect it from there's going to be a lot of wires along here, and basically they'll help protect from the wires getting damaged from the thing skidding along the road, potentially with no body on anymore if it's broken off. So another point worth pointing out is that by this point I decided to optimize the wheelbase and track measurements. My early design had a wheelbase of 620 and I decided to go down to 560, which I think is about 90% of the original dimension, and a track of 241. The reason for that is that it looked like I could get away with fitting everything inside it still, and if I can make it smaller, it's going to make it lighter and easier to manufacture, because the body for the original dimensions was looking like it was going to be quite hard to make. Even on my largest 3D printer, it was looking like it was going to be hard to get that made. So in the end, I was glad I made that optimization, because it did turn out to be quite a construction to make the body shell, as we'll see on subsequent videos. Talking of the body shell, I've got these body mounting rails down the sides there, and also some extra holes at the front and the back there to screw the body shell onto. So the first objective of my chassis development was actually to get to the point where I could order all the sheet carbon fibre parts. So that is the main chassis itself. These bulkheads, oh, what's this? The bulkheads, the springs, this and this top plate. I think that was all the chassis parts. The reason for that is that there was a bit of a lead time on that, so I had to send those designs off for around the end of July. I think I sent them off on the 28th of July in the end, to give time for them to be made, sent to me, and then for me to assemble the car ready for Rossa Round 3. Before I sent the designs off for manufacturing, I decided to make the most of my 3D printing capabilities and use some old filament to print off some prototypes of the parts, just to check they all fitted together as I'd intended. Here's me assembling the suspension system onto the half chassis that I printed off that you can see there. There is some logic behind the snazzy colour scheme, and that is that the yellow is sheet carbon fibre parts and the blue is aluminium parts.
Oh, here's a demo of the Wallace suspension system. These are the springs, so that part there and that part there are going to be 1mm carbon fibre, so they will give the flexibility it needs for the suspension to move, and it's specially designed so that it has not very much suspension travel, but it's quite well controlled in its direction. So you can see if I push the wheel up, you can see the springs flexing there to allow it to move up and down. And then looking from this direction, if I move the wheel, you can see the axle stays quite nice and in line with the ground, which will keep the tyre in the right place.
Let's check back and see how I got on with my requirements list. So, does it package the powertrain selected? Well, the motors are in there. There's space for the speed controllers, plenty of space for the batteries, so I'd call that a yes. The batteries are protected. They've got 5mm of aluminium on 3 out of the 4 sides and 3mm carbon on top and bottom, and they're blocked in by some quite substantial blocks at the front, so I'd say that's a yes. It does use standard wheels and tyres. I'm using standard GT wheels and tyres. It does have suspension with my little rubber cone system, giving a small amount of quite stiff and controlled travel. And it does have adjustable ride height via spacers. It has features that align the front and rear wheels by using the L sections along the side and then the carbon fibre spring plates to align to the subframe, so that feature is there, and the frontal area is minimised. I went down to 90% of the overall size of the car to enable that. Easier to work on, that's a tricky one. I mean, I found when I was building up the parts from 3D prints that it was actually quite tricky to assemble it, and you had to assemble it in a very specific order to actually get it all together. So I think the jury's out on that one, unfortunately, and I didn't really have time to go and redesign it all to improve it, because I just had to release the parts to be made, like the sheet carbon parts. Ease of manufacture, I think that's where I've done quite well, in that there's quite a few sheet carbon fibre parts which are going to get made for me, and any other parts are not too complex to manufacture. So I think they're within my capability. Strength and stiffness. I've designed the car to be quite stiff with its 3mm carbon fibre and 5mm thick aluminium L section construction, and because of that, it intrinsically should have the strength required to keep itself together on a speed run. So I haven't really felt the need to do any further investigation with FEA to prove that. So overall, I think that's quite a good result against the requirements, but maybe there's some doubts on ease of maintenance and working on, and we'll see how that goes later on.
I hope you enjoyed that insight into the chassis design of the Beast car. I'm going to be following that up with videos about the development of the body shell design and also the manufacturing and build of the car. So keep an eye out for those. Thanks for watching.